Hello everyone. One of the students requested that I must do another video explaining the concept of uniformly distributed load. So I'm doing that now using an example. It's a worked example. The uniformly distributed load is 6 kilonewtons per meter over 3,5 meters. So the first part of the equation is your unknown, which is By, times 6,5. Why am I saying is my unknown? I'm taking moments about A, so my By becomes my unknown times the distance of 6,5. The second part of the equation is the uniformly distributed load, where I convert my uniform distributed load into point load acting at the center of that, because it's a rectangular shape uniformly distributed load. What about this distance? I'm taking moments about A, so 3.5 divided by 2 is the distance from the center to the start of my uniformly distributed load. But I am not taking moments about that point. I am taking moments about A, therefore I must add the 3 meters, so that my distance is from the center of my uniformly distributed load to where I am taking moments. So I'm just explaining that. So same thing when you are taking moments about B. When you're taking moments about B, your equation will look like this. There's your unknown AY times 6,5. There's your uniformly distributed load, a rectangular shape, length. You can say length times the height or the magnitude of the uniformly distributed load, and the distance from the center of that load to where I am taking a moment, which is at B, is half of 3,5. So I think that explained rotations. You know the rotations. Remember, I explained how to deal with the rotation, and then you must do your check, sum of verticals, and then this is your reaction at B, this is your reaction at A. If you add the two reactions, they must give you your they must give you 6.5 times 3,5, which is the magnitude of the load that is applied to the beam. Another example. Now, two uniformly distributed load, one on top of the other. Up to the students. Some students can deal with this, separate the 15. Some students can separate the load there. Then this part becomes 21 kilonewtons per meter. This UDL becomes 21 kilonewtons per meter. And then this part of the UDL becomes 15 kilonewtons per meter. I have decided to deal with it separate. Not that is the best method or the best way to approach it. It's up to the individual how you want to approach it. Maybe at home you can try and combine that to be one load of 21 kilonewtons per meter. This one is 15, and see if you're going to arrive to the same results as me. This is the approach. I'm not going to explain that. You should know that. Then this is 15 times 6,5. 6,5 is from there to there, times half of 6,5. I'm taking moments about A, meaning that half is from the center to there. It's from the center to where I am taking moments. That is the first part. The second part of it now, I am dealing with the 6 kilonewtons that is on top there. How do you deal with that? Is 6, which is the magnitude, times the length. Rectangular is acting at the center of that load. What is the distance from the center to where I am taking moment? Is half of 3,5 plus 3. Remember, half of 3,5 is going to take me as far as I point at this point, and then but I'm not taking moments about this point. I'm taking moments about A, meaning I must add that distance to where I am taking moments. Now let's see when we take moments about B. Now we're taking moments about B, AY. I'm not going to explain that again, and the rotations I'm not going to explain. And then let's look at the uniformly distributed load. So in this case, remember, I've treated my 15 as going all the way to the end. So it's 15 times 6,5, and then you multiply by the distance from the center to where you're taking moments. I'm taking moments about B, which is 6,5 divided by 2. Then I go to 6, which is the one on top. 6 times 3,5, the distance is from there to there, which is half of 3,5. Then what do you do about after that? And then you take and then you check whether the sum of reaction add up to the what, to the applied external applied forces. Always approach your uniformly distributed load like that. The question is now, remember the signs, guys, I'm not going to talk about the signs. Remember now, what do you then do if you've got a situation like this? In this case now, my uniformly distributed load is a triangular shape. And you must remember one thing, the center of that shape is not 3 divided by 2. This is a triangular shaped load. So how do you deal with that? To deal with that, remember this. Where is the center of a triangle? So if you're coming from this side, the center of a triangle is 1/3 of that length. If you're coming from this end to the center, it's going to be 2/3 of this length. So we're going to apply the same concept on the uniformly distributed load that is triangular in shape. The ones that we were dealing with were rectangular in shape. That's why it was easy for us to say it's acting at the center of that load. So for a triangular shape, we cannot do that. Instead, for a triangular shape, we must remember now, which side am I coming from? What is the distance from the tip to the center? What is the distance from this side to the center? Let's apply that concept now. Even the magnitude of the load, is gonna be, remember the area of a triangle is half base times height. So it's gonna be half times the base is 3, the height is 6. This is the load. I am converting that UDL now into a point load acting at the center of that triangle. So what is the distance now from the center of this triangle to A, or from the center of this triangle to B? I'm taking moments about A. Therefore, what is the distance from the center to A? Is 1/3 of 3. What is the distance from the center of this triangle to B? Is 2/3 of 3, 2/3 of 3 plus that distance of 3,5, and then you solve your equation. Again, remember, signs are not important. If you are getting a negative sign, make sure you just change the direction of your assumed reactions, because we assume the direction of our reactions, and then if you're getting a positive answer, indeed our assumption is correct. If you get a negative answer, that means our assumption is incorrect. I hope I have explained the concept of UDL. If not, guys, please, again, you are more than welcome to contact me on Teams or WhatsApp or email, and then I'll be able to answer most of your questions. Thank you very much. Enjoy the rest of the day. Bye.